Okay, it's 3 o'clock now. I guess we'll just get going. Okay, so I'm going to talk a little bit about why JRuby is interesting, maybe give some fun demos, and hopefully have time for some questions at the end. I'm Charles Nutter. I've been doing Java since the beginning, pretty much. Doing Ruby actually since 2004 when I went to RubyConf in Reston that time. Working on JRuby full-time since 2006. It's kind of crazy that it's been actually 6 years now of just working on JRuby, and I'm not bored of it, which is even more amazing. And now we moved to Red Hat in the JBoss Polyglot server group, where we're doing some fun stuff I'll show later. So first of all, what is JRuby? Hopefully, has anybody played with JRuby before, ever? Okay, about half the room. So JRuby, you can look in the book. I mean, we've got this book, we've got a deploying JRuby book, but JRuby is basically just Ruby running on the JVM, or a better or different VM for running Ruby code. Most of it's written in Java, kind of legacy, that's what the code base was, but we're moving more and more parts of it into Ruby over time, which makes it a little bit easier for us to maintain, a little bit easier for folks to contribute to. Everything's pretty much standard command line. We have 1.8 and 1.9 features in the box all the time, so you can switch between them if you're opting for one or the other or want to try and play with stuff. And generally, we try to make it pretty much a drop-in replacement for MRI, for standard Ruby. And now there's an asterisk here because there's a few caveats. The low-level Unix stuff, like low-level file descriptor control, process control, things like fork and stuff, not quite there. Some of them we're adding and improving over time, but it's an ongoing process. We don't really support C extensions. In JRuby 1.6, we added support that was built for us as part of the Ruby Summer of Code, but it proved to be a very big maintenance hassle to keep up with, especially Ruby 1.9 additions to the APIs, and very few people used it. Plus, the way that the Ruby C extension API is designed, it kind of crippled concurrency, crippled performance in a lot of different ways. So for the most part, that's kind of deprecated, and we go back to not supporting C extensions. But it may not matter, as I'll clear up later. And then, like I say, some features are different, or some features are unavailable. Object space, each object, for example, is not always available. You have to turn it on. One of those things that are usually done for debugging or profiling purposes, so it may not be a big deal. Trace functions, turn on some debugging support, and then all of the trace events will be there. Little things like that. Some stuff we can't support because VM level-wise, they just don't work, like continuations and fork and whatnot. JRuby 1.7 is the release we're working on right now. It's the one that I'm hoping everybody will try out. Ruby 1.9.3 by default, and we've done a ton of work to make sure that 1.9.3 behavior is pretty close to 100%, especially working hard on encodings, which has been a big effort and a big change in Ruby 1.9. Lots of performance improvements, especially around concurrency, straight line execution performance. We've also added in support for Java 7's Invoke Dynamic, which I'll talk about in a bit. Basically gives us a much better possibility for optimizing Ruby in the future. And we have the beginnings of a new optimizing compiler within JRuby before we even give the code to the JVM. So getting started with JRuby, you need a JVM installed. Most platforms have a build that's pretty easy to get in some way. We have a blog post on the JRuby blog that says how to get Java 7 set up on Linux, Windows, OS 10, etc. Very easy to get it up and going. And then if you're using RVM install JRuby will get the current major release, which would be 1.6.8 right now. I encourage you to try out the 1.7 RC because we're real close to release now, and we'd like to roust out any final bugs. Or you can pretty much just download it manually. There's no build process involved. All the native bits we've pre-built for almost a dozen platforms. So download a tarball, unpack it, put it in your path, and you're ready to go. You got JRuby running. So let's see what running JRuby looks like. Got a basic command line here. I'm going to run my favorite little benchmark, which generates a little Julia set fractal. Okay, bench the flip-flop fractal. And I like this one because it actually builds it in the terminal. Okay, so JRuby is obviously working at this point. Now, I have to show the code for this just because it's hilarious. Now, this must have been part of some sort of obfuscation contest because I have absolutely no idea how that bottom piece of code works. Has anybody ever used the flip-flop operator in Ruby? Yes, of course Aaron has. He uses it all the time. That's why Rails is awesome. But yeah, I mean, this is the feature that most people don't even know what it does in Ruby. And this author's actually managed to stack like 9 of them together to generate a fractal. So if you want some homework for afterwards, you can figure out exactly what's going on there. So my job today is kind of to convince anybody who hasn't played with JRuby or tried it out that it's really the best Ruby runtime to be using. And I put an asterisk here because it's the best for some definitions of best. There are various things you're going to be doing where JRuby is not the right tool, but I'm going to show you where I think it really fits and where the sweet spots are. So first of all, kind of talking about the JRuby team. This is kind of the baseline of why JRuby really works as a project. Most people think of JRuby and the JRuby team as pretty much me, which I do a lot of work on it and I do a lot of talks, but there's much more complicated than that. The real JRuby team is kind of Tom and I up at the top of the team here, orchestrating things, herding cats, and then a whole bunch of other contributors that come and go over time that we manage on the project. This is basically just working on core JRuby and libraries that we've kind of spun off to help make JRuby work. But there's an even bigger story to this in that all of the different JVMs that are out there are also part of our team. They do all of the work to make the VM level operations work, make it integrate with the processor and the operating system, and we build on top of that. So the JRuby team really includes all of the different JVM groups that are doing their great work. And if you look at how JRuby is generally structured as an implementation, we've got the part that's JRuby that we work on, the core team and the contributors and whatnot, parser, the bytecode JIT, core classes, Java integration, other libraries related to encodings and regular expressions that we have, native integration that we've built, and then the JVM at the bottom that implements threading and concurrency, safe concurrency at the VM level, garbage collection, a native optimizing JIT. It has its own JNI, Java native extension C API. And we build on top of this. And what that means is that basically we don't have to worry about any of that stuff. We don't have to sit and work on implementing a GC or debugging a GC, which is even more fun. We don't have to write an optimizing native JIT. The JVM guys do that. And we just have to implement things in the right way to utilize the JVM. And what it means that there's so many pieces of JRuby that we just don't have to do. We don't have to worry about all of this stuff. So we can focus on making JRuby better, and it's how we've actually managed to catch up with and almost match now Ruby core implementation as it happens. JRuby 1.7 has a hidden --2 2.0 flag that will turn on several Ruby 2.0 features that aren't even released. We've kind of caught up now, and we can keep up with regular Ruby development at this point. And the bottom line here is that we could basically stop working on JRuby today and have no one commit anything else, and it would continue to get faster because the JVM guys are there and continue to implement that stuff for us. So that's future-proof. As long as the JVM is going to be around, we're going to continue to get better, even if we don't do anything. All right, and the next area that JRuby kind of shines is in cross-platform support. So there's been various folks who've said maybe JRuby is the best way to do Ruby on Windows. At one point, Mott's even said that maybe if you're having a lot of trouble on Windows, you should try JRuby. We've spent a lot of time trying to make sure that JRuby runs well on Windows, runs well on lots of different odd or exotic platforms. And again, we get a lot of that because the JVM has been built and tested and runs really well on all these different platforms too. More interestingly, we can run on Dalvik, which is Android's VM. There is support for a library called Rubato that lets you write Ruby applications in JRuby, deploy an application to the market, and have it run as a normal Dalvik application. We've had that for a couple of years now. And then any of the embedded JVMs. Oracle recently made their embedded hotspot OpenJDK free for general purpose use. And so if you're running on small devices and doing general purpose sort of embedded computing, you can use JRuby there as well. Here is from our issue tracker. Any OpenVMS people here, or AS400? Anybody? No? Not surprising. So OpenVMS, which is still alive and kicking, there's a couple guys that have been doing it for 25 years and continuing to maintain those systems. We actually have 15 mostly closed, a couple open issues in our tracker for OpenVMS. If you look at our list of platforms that we support for native FFI level, which is the Ruby FFI DSL and any native features that we need to do that kind of route around the JVM. We obviously have some interesting ones here like S390X Linux for mainframes, PowerPC Linux. We don't, unfortunately, have the OpenVMS or AS400 builds yet. A little bit of challenge getting those. But we work very hard to make sure that what you get in the box with JRuby will run anywhere there's a JVM without having to build anything. This is a list off of Ruby Gems that I ran today. These are all the libraries in rubygems.org that have a Java platform version. Some of these only have a Java platform version because they're made to run on JRuby. But the basic idea here is that because these are all built with JRuby in mind and with the JVM in mind, no native C extensions, no library requirements on the system you'd install, no build of the extension that might fail. You pretty much just install it and it runs. It's a binary that comes down and you're done. And even better, you can pull this all into a single installable package, ship it to another machine, and it'll run there just the same. So platform-wise, you can kind of talk about servers too. Any Java-based server can host Ruby. So if you're in a shop where they're mostly doing Java, or if you want to do Ruby development in a shop that's mostly Java, you can deploy it on all the same servers. But we also have servers that are designed more with Ruby folks in mind. Trinidad is basically the Tomcat application server, stripped down and wrapped with a nice Ruby command line so you can run it like a Unicorn or Puma or a command line server. Still has everything that Tomcat can do with multiple threads, high concurrency, nice HTTP pipeline, but it looks pretty much like you're running a regular Ruby server at the command line. Torquebox is a little bit more interesting because it takes that same concept and then provides all of the services from a larger scale enterprise app, again, with nice Ruby APIs and Ruby configuration. You never really even know you're running inside a JVM-based server, but you've got all this stuff. So if we look at a typical Ruby application, it starts out simple. We've got our server, we've got our web front end, rack, and then maybe a Sinatra or Rails back end of some kind. And then we decide, okay, we need some delayed jobs, we need some tasks, scheduled jobs, background jobs to run. So we run another server to do that for us. Okay, now we need to have some timed jobs that run at particular times a day. So we're going to set some stuff up in cron and make sure that that runs on schedule. Maybe we need to monitor this, make sure it stays up, make sure that our servers are still running and they're doing what they're supposed to. And so as these applications grow, they get more and more complex as they have all these pieces spread out, different APIs for each, perhaps multiple implementations of the APIs for each, and you have to orchestrate all this together and make sure it keeps running. Well, the idea with Torquebox is that the JBoss server basically provides all of these services, messaging, caching, clustering, in and out of memory caching, scheduled jobs, background jobs. All of this stuff is in the box. And so it puts a nice Ruby front end on the whole thing. You get all of that in the same box, managed through one tool, one process, and it does everything that your cluster of services would have done before. Here's the short list of all the stuff that comes in the box in Torquebox. So if you're building a JRuby application, you basically can do all of this in one server without having any other external dependencies or any other external libraries to deal with. A lot simpler. And Torquebox is just gem installable. And you can pull it down, start it up, and have all this stuff running on the system without installing anything else. All Ruby APIs. And they're actually pretty nice. So here is the basic configuration, which Ruby version mode you want to run in. Do you want things to be jitting and compiling at runtime or not? Do you want debugging on? Do you want it to be interactive? It can spin up a little IRB console on the server so you can check, actually connect to the server, see what's going on, run queries, and make sure things are doing what they're supposed to. And all the configuration comes in both a Ruby DSL form and a YAML form, so depending on how you want to set it up. So let's look at messaging specifically. Here's the Ruby and the YAML versions for setting up a queue and a topic, and you're done. All this goes in the same torquebox.rb config file, and you've got messaging queues set up. And calling them has a nice, simple Ruby-feeling API that goes along with it. No hassle of doing all of the typical JVM server stuff, no hassle of spinning up a separate process and making sure that's running properly, and going out of process to do all of your messaging. This is pretty much it. All right, so moving on to libraries. If you look at Maven, the standard repository of libraries for Java JVM applications, there's 340,000 versions of different jars in Maven right now. Compare that to 35,000 gems in rubygems.org. So we're talking about a 10-to-1 difference in how much there is available for libraries if you're running on JRuby. And all of these can just be called as if they're a normal Ruby library. So very few of these have any native code. You pull them down, call them from your Ruby code, and you've got access to them. This is an example of an application, a commercial application, that uses the Batik SVG library to do a production flow simulation, like a supply chain management kind of stuff. And this was done for, I think, Department of Defense, and then spun off as an external project that other folks could use. If anybody's ever played with Redcar, there's an editor called Redcar that is written entirely in Ruby and uses a few JRuby libraries or JVM libraries to do the GUI portion. It uses SWT to do some of the back-end stuff. It has support for Clojure, support for other languages, all within the same editor, and basically all written in Ruby from top to bottom just by calling these libraries. And actually, I want to show this. So JavaFX has been maligned for very good reason in most cases. JavaFX is Oracle's new attempt to build a new GUI toolkit for JVM-based applications. It was originally Sun's attempt to create a GUI toolkit plus a language, and it was a horrible abortive attempt at putting all that together, so that's gone now. But it means that we have this library that we can call and use directly. Basically as a scene graph that you build up with all of your vectors, all of your drawings, all of your 3D elements, and then it tosses it into an optimized back end, regardless of what platform you're on. The example I'm going to show, there's a basic JavaFX example of doing an analog clock. And you can see here we're creating a couple paths. So we're drawing the minute hand and the hour hand. They're going to be filled with black. And then we just have basic JavaFX primitives to say, move the target here, draw this line, draw an arc, rotate it in this particular way, and then it all gets optimized and thrown into the graphics backend the way it's supposed to. Let's see if this one actually works. Okay. So there we start up with JRuby, and there we go. So this is all implemented in Ruby, the logic of it. The building of the UI is all done sort of as a builder API, and there are various DSLs that people have written around this for Ruby to build this stuff up. But you can do accelerated graphics, 2D and 3D graphics, with a library that's basically built into the JVM. Now another one that's fun here. How many people do Minecraft, play Minecraft at all? A few folks. How many people know what Minecraft is? Okay, so most folks know what Minecraft is. So for RubyConf last year, Tom gave a talk on his library Prugin, which is sort of a Japanese-y mutilation of plugin, but it's basically a Ruby API that allows you to write plugins for Minecraft. Very clean DSL for handling events, adding event listeners, running different scripts and whatnot, controlling different objects in the system, querying objects. And since then, he actually worked on an implementation of Logo that runs on top of Prugin in the Minecraft runtime. And this is an example of basically a little Prugin Prorogo script that will draw a pyramid of a particular length on a side. And of course, since this is Minecraft, we have 3 dimensions, so there's a turn up and a turn down, as well as the typical turn left and right. Let's see what this looks like. Yay, so here we are in our little Minecraft world. That's actually Tom's girlfriend hanging out. Okay, so we're going to start at that point, whatever square you're pointing at. We're going to draw a pyramid that is 12 on a side. Tom's deciding 12, 8. And we'll make it out of gold ore, just for this demo. And of course, we don't have a turtle, so we use a chicken, because it makes sense. It's Minecraft world, and we'll have a chicken draw our graphics. And there we go. And this is all, it's just a simple Ruby script running on top of the Prugin Ruby backend for Ruby front-end plugin stuff for Minecraft. And there we go. We have our 12 by 12 pyramid drawn by a chicken. Who says you can't use JRuby for useful things? And then we'll undraw it, and then it's gone. It has memory of what it's actually done. Okay, so that's fun. And these are all just libraries you can pull down. I mean, it's just a thrill to play with all this fun stuff. So Threepence is another library that Tom has worked on. It wraps the Ardor 3D library, which is using a lightweight Java OpenGL backend, and then providing a scene graph and other stuff on top of it. And it's actually, if you go to Tom's account on GitHub, Enebo, E-N-E-B-O, and look for Threepence, you can basically just clone this and run it. And it has all of the native libraries that are required for it built in. So on pretty much any platform, if you have Threepence, you have JRuby, you have a JVM, you can do 3D graphics and 3D games. And the example he thought would be fun to show is there's a little skybox that just spins a cube around in a blue background. Let's run that one. There's another one I'll run too that's kind of fun. So this is Neo, the Neo demo in here. And so all the logic of what's actually happening to the 3D objects is implemented in Ruby, in JRuby, and it runs fine. There's an interesting bug there, if you notice, when the one that's in back passes in front of the, the front one. So, but again, built-in stuff that we can do on the JVM, and we can use existing libraries from Ruby without any hassle. And there's another one that's a little bit more entertaining. So here, this is bubble mark, a benchmark that's basically just showing a bunch of bubbles bouncing around. You'll notice it starts out about 100 frames per second and then optimizes as the JVM gets faster. I think this will end up somewhere in the 900 range, maybe a little bit faster, 1100 frames per second, more frames per second. But then we can challenge JRuby in the JVM a little bit by throwing 128 of these in here, still doing pretty well, around 700 frames per second. We'll drop it back down. We got ball-to-ball collision, and actually vsync it so it always sticks right around 60 to 100 frames per second. So it's nice and clean, and we have predictable. Again, the logic for all this is implemented in Ruby, calling into a JVM library that then does all of the fast graphics for us. Okay. Wait a minute. That is the wrong talk. How did that happen? Go away, go away. Go away. Go away. There we go. That's weird. Went to the back. Okay, so that's libraries. And there's obviously a lot of other practical libraries out there that can do all sorts of fun things for you too. But pretty much any JVM library that's available, you can pull it down and just call it from Ruby code. So more low level now, talking about VM level issues like garbage collection. Has anybody had garbage collection issues running on MRI, pauses, just too much CPU use in general? And that's not uncommon as far as running with MRI. So the issues is that basically applications data set, either within a single run or over time as the application becomes more complicated, will grow. And you'll have a larger application, more data, more objects in memory. And Ruby itself is very object heavy on top of that. So eventually you do have a problem with this on MRI. Let's look at, so on the JVM side, we have lots of different GC options, many different to choose from that scale to different sorts of loads, scale for multiprocessor systems, and these are pretty much the best garbage collectors in the world. If you look back at GC research over the past 15 years or so, pretty much every implementation of a GC has mentioned or has been implemented specifically for the JVM. And a lot of that work is now available for free in OpenJDK. So here's the OpenJDK ones that are actually interesting. The default is usually to run with the parallel collector, which does stop the world. The application does stop, but it uses as many cores as you have in your system to do that collection as fast as possible. The concurrent collector tries to avoid pausing the application as much as possible and runs concurrently to the application itself. G1 is kind of intended to replace the concurrent collector, and it allows all generations, all different objects to be collected concurrently up to some certain limit. And then there's a serial collector that's very fast throughput, but it stops the world for every collection that goes on. So I have a couple demos I'm not going to run here. I've pre-run these and gathered some metrics about GC in JRuby versus MRI. So the first one's GC Demo 1. It has a lot of GC, which is a mix of old and young objects. So objects that have been sticking around for more than a few seconds, combined with stuff that's being spun on really quickly. And then the heap steadily grows over time. Here's the example. So we have a couple different levels of loops. The innermost loop, the per loop, basically just spins off and creates 100 of these simple objects. So that's the young objects that are getting collected very frequently. The next loop out basically just creates a longer and longer chain of objects, a linked list of objects. So that grows in memory, it gets old and gets promoted to the old garbage collection generation, and then gets collected at some point. So both garbage collectors being exercised here. And so I went to run this on MRI 193 and JRuby just to get like a general idea of how much garbage collection is happening. And I got something like almost 8,000 collections happened during this 10, 20-second run of this script. And I threw this into a graph and had to make it logarithmic so you could even see how many garbage collections happened during the JRuby run. It was under 100. It was something like 75 total garbage collections that ran during the entire script. And this is not atypical. Applications that run on JRuby are generally not going to be GC bound. If we look at how much time is actually being spent for GC, it's getting up into the 12, 13% range for MRI. And now the thing to think about is that this is per process. So if you've got every single process in the system using 12 to 13% of its CPU time just to clean up garbage, you're wasting a tremendous amount of CPU to keep all of those concurrent connections and all those concurrent processing going. Did a measure of how long the GCs were actually taking. You can see that MRI does pretty good for small heaps. And that's one reason that for small applications, command line apps, little short scripts, MRI is still probably the best way to go. It starts up fast. It runs pretty fast at small levels of load, small application data sets. But very quickly, as the application gets into a typical Rails size, you can see that these pauses, or that the amount of time being used for each GC is going up and up all the time. If you get to an application that's 200, 300, 400 meg in a given process, you're getting up to the point where you're waiting a half a second for garbage collection to run when it runs. So GC Demo 2 is a little bit different. Frequent GC, but it's all young objects. And then it lets the heap grow and create larger and larger objects. So over time, it's not garbage collecting as much, but it's a larger and larger section of memory that's being used by the application. So this is the example here. This will continue to run and just build up memory and make the application larger and larger while it does a massive amount of young generation collecting on these little objects. So GC time comes out a little bit closer here. For a longer run, JRuby would probably pick up because over time an application would settle into a particular set of old objects and the JVM would just not even look at them for GC purposes. Now this one is a little bit scarier. These are real world-stopping pauses in the application as it goes on. So obviously, JRuby runs this a lot faster, first of all, than MRI. But you can see as the application grows, as the amount of data on the heap grows, the whole application is pausing more, getting up into a quarter-second pause times towards the end. And this is pause times that will be that way for the rest of the application lifetime until you kill it and restart it, and then let the process begin again. Whereas JRuby can handle gigabyte heaps, and it's going to be pauses in the 0.01 range almost all the time, or lower. So yeah, this is your application, and these are the pause times that users are starting to see, and here's the opposite. They're not happy with this. More and more requests have to wait for those GC pauses, and generally people are not happy. So in general, JRuby running any typical Ruby application, GC is not going to be a problem. You're going to have much more predictable applications, and you're going to make a lot better use of resources on the system. All right, so threading. JRuby, of course, is based on the JVM, which has real parallel threads. And there's not much else to it. We don't do anything special other than just make a Ruby thread map to a JVM thread and let the JVM run with it. That also means that one process can handle all the cores in your system and saturate them. It can handle all the requests you want to throw at it concurrently. And you don't have to have extra processes. You don't have to waste those resources. So here's a contrived benchmark that basically just counts up a bunch of numbers. There's the single-threaded version that just goes straight through it, and then a threaded version that spins up 10 threads to break it up into 10 pieces. Now, if we run this on Ruby 1.9, unthreaded, you'll see one core will saturate, like you'd expect. If we split this up and we have the 10 threads do it, well, we use basically the same amount of CPU spread out across a couple of cores, but we're not saturating all the CPUs in the system. We're not using up what's available. Now, if we run on JRuby, and I'll note that every other core here is a hyper-threaded core, so sometimes they do their work, sometimes they don't. So JRuby unthreaded, we have the one thread that's pretty close to 100%. You'll notice on the left there's a thread that's maybe around 30%. That's the JVM actually doing its GC in the background and picking up objects while the application runs. If we run this with all the threads, then there we go. We saturate everything. We're actually using the system in one process without having to do out-of-process communication, without having to manage all these different instances. And then as far as scaling this, here is a threaded reverse is a benchmark from JRuby's suite that basically just takes a large string and tries to manually reverse it as fast as it can. So with one thread versus two, we're almost twice as much. And then you can see it's kind of a tapering off effect. But it does actually scale with the number of cores, with the number of threads that you're throwing at it. And you notice, like I said, it's nonlinear. It's kind of a curve down to the bottom. So more work and running through this stuff faster means more objects. And eventually you start to saturate the pipeline of, for example, my machine. A machine with higher memory pipeline, faster memory, you can scale a lot more linearly across processes or across threads. All right, last section here. The JVM has been around for a long time, and as a result, there are tons of tools available for it. Visual VM, YourKit, NetBeans, JX Insight are just 4 that are fairly commonly used. There's dozens of others for doing heap analysis, for doing live profiling of applications. We have a couple tools built in. We have -- profile, which will give you a basic profile of the application, a graph version that will show you call trees and which call trees are the heaviest hit. For doing memory profiling, you can turn on a feature in JRuby that allows the JVM to show normal classes in object profiles. So any of the JVM object profiling stuff will work with regular Ruby classes. And then there's a lot of command line profilers that are built into the JVM that do a lot of this too. So monitoring is kind of the other half of tools. When you've got an application in production and you want to keep an eye on it, the JVM has something called Java management extensions built in. And there's a couple different gems that allow you to query or register management interfaces from a Ruby application. JConsole and Visual VM are the typical ways that you access these. I'll show a little bit of Visual VM in a minute. And there's a lot of servers that provide additional tools, like how many requests per second you're getting in, basic profiling of request end-to-end, that you can query it all remotely, and it's just a standard interface that any of these tools can access on those servers. New Relic and the other external application monitoring folks also have JVM support that's essentially built on top of this. So you can have Ruby level monitoring and VM runtime level monitoring to go with it. So Visual VM is what I want to show a little bit. There are CPU, memory, thread monitoring stuff built in. There's profiling for either instrumented or sampled profiling built in that you can run on any application. Visual GC is really cool, which is what I'll show. And then you can pull off heap dumps, analyze them, see how many objects you have in memory, and then go and investigate why you have extra objects, why you're leaking, and so on. Here's a view of it actually doing the memory profiling. So here we've turned on the flag that allows Ruby objects to show up as normal JVM objects, started up a basic Rails application, and this is what memory looked like. Rails does a pretty good job of keeping its own footprint pretty small, but RubyGems has a lot of libraries and a lot of gems that it's loaded in. So that's what shows up as the largest part of the heap for a base application in this case. Here's another one actually profiling Ruby application running. So we've got a Rails application, env config is apparently getting hit here as the top one, and then it goes down from there. So regular Ruby methods showing up in a JVM monitoring tool. And I'll show a little example of this. GC demo 2. We'll run GC demo 2 and actually hook up to it with Visual VM. So usually on most systems, if you've installed the JDK, you've got JVisual VM as a command that you can start up and connect to any application. Here it sees that we've actually got a JRuby app running. The Visual VM guys have built that in. Bring that up. And like I said, there's monitoring of basic stuff like CPU, how much heap is being used over time, all live. I can force the system to do a GC. I can do a heap dump and then analyze it for what objects are available in memory. Here's what all the threads are doing. Mostly this is a simple script, so it's all the JVM baseline script threads, and our one JRuby thread is the main thread down here. But this is a little bit more fun. This is actually showing the GC running live. So we have each of the different generations of GC. It shows how much allocation is going on, how big they're getting, the nice sawtoothing effect of a good non-leaking application. And you can see the bars going up and down as the different generations fill up. So if you see nice sawtooths like this that mostly stay the same height across the top, you got a good clean application. If you see that steadily increasing, you might have a leak, and then you can use other parts of the same tool to find that. All right. Last section here.
So performance, this is where I work on in JRuby most of the time. So we're running on top of the JVM. JRuby basically will compile Ruby code down into JVM bytecode, and then the JVM will take that bytecode and do its own rounds of optimization. And this is some of the best JIT technology in the world. It's definitely the fastest managed runtime in the world, at least as far as running Java-type code that it can optimize. And in Java 7, we're actually starting to take advantage of that same level of optimization because they added Invoke Dynamic, which is a base JVM support for doing dynamic invocations like we have in Ruby. So Invoke Dynamic, if we look at JRuby's evolution over time, we've got a little simple piece of Ruby code here that calls from foo to bar and bar to baz. On previous versions of Java, 5 and 6, we have a bunch of call logic in between each of these steps. And that kind of obscures the fact that we're calling from foo to bar as far as the JVM goes. It doesn't know how to optimize these pieces together. With Invoke Dynamic, all of that stuff kind of disappears. The dynamic call logic is built into the JVM itself. And so it all goes away. The JVM sees that straight through path for optimizing, and it can do the optimizations that it would do for any other statically typed language on the JVM. Literally, we can have Ruby code that runs as fast as Java or Scala or any of those static languages. A little bit more, a different way of looking at inlining. This is a little script that I ran. On the bottom is the assembly, which I'm sure everybody can read, for what it actually generates for the code for Invoker. It's actually inlined foo. So it runs long enough, the JVM sees us doing these dynamic calls, and it sees that Invoker always calls foo. And so instead of doing the call to foo every single time, it actually will just put that value of 1, or whatever foo is doing, in the body of Invoker. And then if it runs a little bit longer and it's able to optimize a few more levels, well, it'll see that Invoker isn't doing anything special. We'll inline that right into the loop here. And so we actually have a loop that is doing no calls other than the math calls that it does to run the loop. Maybe it'll get rid of that. It sees that that value is never actually used. It's loaded from a known place in memory and then ignored, so we're not even going to do the lookup for that value anyway. And then this loop actually doesn't accomplish anything. So if we get the JVM to understand all of these different pieces well enough, this even disappears. This is one of the wonderful challenges of benchmarking on the JVM. You have to make sure your benchmark actually accomplishes something, or it will actually optimize the whole thing away. And this is now feasibly possible with Ruby, that we can get the same sort of optimizations for Ruby that JVM guys have been talking about for years. That's a nice one. I like that. Actual numbers. You'll notice none of these are silly fib benchmarks. These are more real-world benchmarks. Doing base 64 encoding, Riches is kind of a VM simulator that does a few things that are difficult for VMs, like polymorphic calls, multiple targets at the same call site. Neural is basically a neural network simulator, a very simple CS 101 version of it. Mandelbrot just generates a Mandelbrot to the console many times. And red-black builds up a very large red-black tree, walks it, searches it, deletes elements, and whatnot. This is JRuby before Invoke Dynamic, running on Java 6. And we're already doing pretty good. We're generally faster than Ruby 1.9 for this stuff. And with the Invoke Dynamic stuff, much faster. Some of these cases are actually starting to get as close to what you would have for Java performance if you implemented essentially the same amount of work to be done behind the scenes. Another more recent benchmark, Chuck Remus ported a C++ implementation of Dijkstra's smooth sort. You can go ahead and look at that if you want to get more details on it. And again, we're doing pretty well here. Ruby 1.9.3 is definitely better than Ruby 1.8, but we're pretty much blowing it away with Invoke Dynamic here. And even other VMs that do native code generation are still not quite caught up to what the JVM's JIT can do here. And this is, again, I could sit back and do nothing, and the JVM guys who are optimizing Invoke Dynamic would continue to make these graphs go up for JRuby. What about Rails? Rails is the biggest real-world application of all. Here's one tweet that somebody ran this and said that it was way outperforming 1.9 on their particular application. And the caveat here is it's going to vary depending on what your application does. If you're doing a lot of database hits and creating crap loads of objects in memory and doing a lot of database queries, it's going to depend more on how fast the database layer works and how fast those queries can be generated and how fast the objects that go with them can be generated, which is almost all native in every implementation. But on your application, if you've got a lot of Ruby-intensive computation that's going on, it's very likely that JRuby will be able to run it considerably faster. The Torquebox guys have run some of their own numbers, naturally. So here's the basic straight line performance numbers, latency-wise, TorqueBox is far and away the best. Requests are returned very quickly, even at higher loads and with more concurrent requests. It maintains very consistent latency. And then throughput, you'll see that both of the Ruby 1.9 versions, even though they're spinning up their threads or their processes in the background, they eventually peak and they can't handle any more load. Too much memory pipeline, too much GC overhead, whatever it is, the JVM versions, both TorqueBox and Trinidad, can go a lot higher. And this graph just continues to go up if we extend it. More on the resource utilization side, we see TorqueBox and Trinidad as far as CPU use, and almost always using less CPU to generate the same requests, and in a lot of cases generate those requests more quickly, and using less memory in the process. So we've got more free memory in the system running with the JRuby versions versus an actual scaled up version of the Ruby 1.9 stuff. All right, so that's about all I have. Really want people to just try this out. We work on JRuby solely so that you can try out JRuby. I mean, I'm paid to work on it, but I'm not like, it's my day job. It's not something where I'm expecting to get millions of dollars off this. I do this because I like working on it and because I like to help people run Ruby apps better. Turn on JRuby and Travis if you have any libraries. Travis has been by far the greatest help for getting Ruby libraries to run across different implementations. Hopefully we can get platforms as part of that too. And let us know what you think. Check out the books if you want to go straight to deploying applications. We've got the Deploying JRuby book, which a lot of folks are enjoying. The basic JRuby book talks a lot about Java integration, how to get JRuby up and going. And you know, it's up to you to help us make JRuby do what you want it to. If that's run faster, use less memory, support more libraries, just let us know. And that's what we do. There's the books again, and there's my information. So that's all I have. We've got time for questions. Anything? Yeah, here. Okay. If you switch from MRI to JRuby, what are the caveats to run into? By far, the biggest one is the C extension issue. Most applications that have grown up in the MRI world use a lot of different C extension libraries for graphics or whatever else, or for goofy things like Markdown. RDiscount's been a pain in my butt. But in most cases, there is usually an API. A lot of the C extension gems have a -Java version that has a Java library that runs it behind the scenes. For the ones that don't, there's usually an API-compatible replacement, or there's almost certainly a JVM library that you can swap in. And that's a little bit more work because you're going to have to work with a different API, but there's basically no C extension library on MRI that doesn't have some sort of equivalent running on JRuby. It just depends if it fits right, if it's a drop-in replacement or not. The other caveat is startup time, which is an ongoing problem for us. Mostly this is JVM issues that it just starts out cold. The entire implementation has to be compiled by the JVM to even parse things fast. This is improving with the Java 7 and Java 8 builds, and with JRuby 1.7. Folks are reporting that it's 20, 30, 40% faster startup time. There are things like JRuby RSpec guard stuff that will allow it to run tests in the background, so TDD can be a little bit easier. And we have support for something built in called Nailgun, which basically keeps a warm JVM in the background and just tosses it commands. That can make per command runtimes be down below a second almost every time. So there are a few little mitigating items you have to think about making the migration, but in general, there's ways around all of them. All right, well, we'll call that a day. Thanks very much.